Hello everyone, welcome to Form 4 Additional Mathematics, Chapter 4, Indices, Surds and Logarithms. So this is the part 2 video where we are going to discuss solving problems involving indices. So before we go to look at the actual problem, we try to look at one of the skills that we can use when we want to solve the unknowns involving indices, where if a to the power of m equals to a to the power of n, when the base number is the same here, we can conclude that the indices m equals to n. And also if a to the power of m equals to b to the power of m, where the indices now is the same, we can conclude that a is equals to b. The base number are equal. Of course, with the condition where a is more than 0 and a is not equal to 1. Because if a is equals to 1 here, 1 to the power of any values is still equals to 1. So m can be any value, like for example 1 to the power of 2 equals to 1 to the power of 3, but 2 is not equal to 3. Okay, we try to look at an example. Solve 2 to the power of x equals to 32. Solving here means find the value of x. When the indices is an unknown, we can try to change the right hand side to indices number where the base is also 2. So you know that 32 is actually 2 to the power of 5. So when they have the same base, by comparing the indices, you know that x equals to 5. Now we try again. So when the indices is an unknown, we can try to change or convert the numbers so they become the indices number with the base of 5. In order to do this, we need to move the numbers here. With 2 we move here, becomes divided by 2. So 2 divided by 2 becomes 1. And then 6 to 5 is actually 5 to the power of 4. If you have problems with this, you can use try and error. 5 times 5 times 5 times 5 until you get 6 to 5. Why you use 5? Because 5 is the base number for this side. So after you get 5 to the power of 4, you can use the law of indices. 1 over a is a to the power of negative 1. So 1 over 5 to the power of 4 is actually 5 to the power of negative 4. By comparing since the base number is the same now, by comparing the indices, x equals to negative 4. Next example. So the indices here is the unknown that we are looking for, that we are going to solve. But since there is a fraction here, we cannot combine these two. So what we can do here is, first, we break this down. Remember the law of indices. 3 to the power of x plus 3 is actually 3x times 3 to the power of 3. Here, 3 to the power of x plus 2 is actually 3x multiply 3 to the power of 2 as shown here. Okay, so this is actually this is actually this, using the law of indices. So when you get this, you can factorize 3 to the power of x. 3 to the power of 3 minus 3 to the power of 2 is actually equals to 27 minus 9, which is 18. So you move the 18 here, you get 2 over 18 is 1 over 9. 9 is 3 to the power of 2, and then again we use the law of indices here, this part becomes 3 to the power of negative 2. So x, by comparing the indices, x equals to negative 2. Now for this part, if a to the power of m equals to b to the power of m, then a equals to b. When the indices are the same, the base number are equal. So for this case here, so solve x minus 1 to the power of 5 equals to 1024. If you want to use this relation here, you need to change this number into indices with a power of 5, because m and m here they are equal. But in this case, use try and error. So you find that 4 to the power of 5 is actually equals to 1024. So when the indices are the same, by comparing the base, x minus 1 equals to 4. So x equals to 5. Another way to solve this is actually you find the fifth root for both sides. You find the fifth root, cancel off with the power of 5. Here you find the fifth root, you get 4. Then x minus 1 equals to 4, you find the answer. For the last example, we're looking at a real-life problem here. A ball was released at a height of h centimeter from the surface of the Earth. The ball will bounce with 90% of its initial height. So after it is released and it bounces, it will only reach 90% of the initial height after the ball hits the surface of the Earth. The height of the ball after L bounces, so L here represents the number of bounces, okay, is given by this. So after L number of bounces, the height will be this. So we look at the question here, it says, determine the height of the ball in centimeter when the ball was released. It means it is the initial height. So when it is an initial height, there were no bounces. The number of bounces is 0. So we substitute 0 into the equation given. L here is equals to 0. We calculate this, we get h equals to 10 centimeter. So how about the height after 10 bounces? After 10 bounces, the L will be 10. We just substitute 10 into the equation given, and we can find the answer, which is actually quite easy if you understand the question. So this is the end of the part 2 video for the indices. In the third video, we are going to look at surds. I'll see you then. Thank you.